Bismillahirrahmanirrahim. Assalamu alaikum. How are you, dear students? Today we will discuss topic from course Inorganic Material Chemistry, and course code is CAM 3115. Topic that we will discuss is properties of advanced materials. In previous lecture, we discussed mechanical properties of advanced materials, and today our topic is electrical properties. Let's start our discussion. Now we will discuss these contents into two lectures. So in today's lecture, we will stop discussion at electrical conduction and band gaps and their mechanism of electrical conduction, and from semiconductivity to superconductivity and the application of superconductors we will discuss in next lecture. So in this lecture, contents that we will discuss. First, our main topic is electrical properties of advanced materials. So in electrical properties, when we talk about electrical properties, then these are related to electricity or electrical conductivity. So first, we will talk about electrical conductivity, and then we will discuss about conductivity and resistivity, what is difference between them. And next we will discuss electrical properties of materials, on which kind of or what we can study in if we are studying electrical properties of materials. Then we will discuss the types of materials that may be conductors, semiconductors or insulators, and later we will discuss their detail. The next thing that we will discuss under the electrical properties of materials, on which these are based, are electrical conduction or band gaps. And in electrical conduction and band gaps, we will discuss about types of band gaps and mechanism of electrical conduction. Then we will discuss semiconductivity, and in semiconductivity we will discuss doping, and that may be intrinsic semiconductivity or that can be extrinsic semiconductivity. And later on we will under this topic semiconductivity, we will discuss the applications of semiconductors, how we can modify our materials and we can apply them in different micro electronics. Next we will discuss in electrical properties of materials, we will discuss effect of temperature on conduction. And the final thing that we will discuss is superconductivity, and we will discuss how we can make superconductors, how we can modify materials into superconductors, and their application on applications of superconductors in electrical industry or microelectronics. So overall properties, electrical properties of advanced materials, we will discuss in our next lecture. Electrical properties of materials could be divided into three types on the basis of electrical conductivity. These include conductors, insulators, and semiconductors. And conductors are further divided into metallic conductors and electrolytic conductors. So mostly solids show electrical conductivities of in the range of from 10 raised to power minus 20 to 10 raised to power 7 ohm per meter. As electrical properties are related with electrical conductivity, so we can say that materials which have capacity to conduct an electrical current, that are conductive, or they have electrical conductivity. So if electrical conductivity of material is greater, then we can say that it is easy to pass electricity through it. So any material from which electricity can be easily passed, that are known as conductors. So mostly metals are good conductors of electricity. Before going to discussion about conductors and other types, first we should know few terms, that is basic and important terms, that are conductivity and resistivity. So what is conductivity? Actually, conductivity is the measure of how easily electricity can flow from any material. So if electricity can pass easily from any material, then we can say that have more conductivity, or that material is more conductive, or that is conductive material. So what is electrical resistivity, or what is resistivity? Electrical resistivity measures how much a material resists the flow of electricity. We can say that conductivity and resistivity are opposite to each other. So these both are inversely proportional to each other. So we can say that when conductivity is lower, then resistivity will be higher. And the same way, when resistivity is lower, then conductivity will be higher. So if any material that have low resistivity, its conductance will be more. So we can explain this by this equation, that is equal to rho is equal to 1 over sigma. So resistivity is inversely proportional to conductivity, and similarly we can say that conductivity inversely proportional to resistivity. So we can represent resistivity by rho, and it is measured in ohms meter, and conductivity is denoted by sigma, and its units are Siemens, that is 1 over ohm meter. When we are going to discuss electrical properties of materials, then here we will discuss, I have told you that there are three types of on the basis of conductivity, that are insulators, conductors, and semiconductors, and other type that we will further discuss is the superconductors. And other important thing that we will discuss about energy band gaps. And further thing that we will discuss is in semiconductors is the doping, and that could be intrinsic and extrinsic doping. So conductors are that material which allow electric current to pass through them. So any material that allow electricity or electric current to pass through them are called conductors. So mostly conductors have conductivities in the range of 10 raised to power 4 to 10 raised to power 7 per ohm per meter. And metals, mostly metals have conductivity in the range of 10 raised to power 7 ohm per meter. And metals are best conductors of electricity. So if we want to take example of conductors, then metals are good conductors of best conductors for electricity. And examples of conductors metal conductors are copper, it could be silver, iron, etc. So metallic conductors that allow metallic conductors are those conductors which allow electricity to pass through them without undergoing any chemical change. In metallic conductors, no chemical change may occur, but it is due to that conductance is because of the movement of electrons that are present in that metals. So metals can conduct electricity in both forms. They can conduct electricity in solid form as well as in molten state. So this conductance in metals is due to the free movement of electrons, and this is without any chemical change in it. So example of metallic conductors is copper, silver, iron and gold, etc. So other type of conductors, we said that we can divide conductors into two types. One is metallic conductors and other is electrolytic conductors. In case of metallic conductors, the electricity can pass through that metallic conductors without any chemical change, and that electricity or that conductance is due to free movement of electrons. So in case of electrolytic conductors are those conductors which allow the electricity to pass through them by undergoing chemical change. Like in electrolytic conductors, some chemical change may occur and then they can allow electricity to pass through them. So this is also possible in ionic solids, like conductance in ionic solids is due to the movement of ions or other charged particles. So in this example, you can see in left side figure, you can see that ionic solids in solid state will not conduct electricity, but on the right side you can see that these are in free form. These charges are in free form. So ionic solids can conduct electricity in molten state or in aqueous solution. For example, on the left side you can see there are crystals or solid material for sodium chloride. Then it cannot conduct electricity because it is in packed form, and here charge cannot move freely. But in case of when you make a solution of that sodium chloride, then it will convert into ions and electricity can pass through them. So they are known as electrolytes or electrolytic conductors. So in left side figure, so on left side you can see that this these ions are not free to move. These are in packed form, so electricity will not pass through ionic solids. But on the right side you can see in figure that there are spaces between these ions and they can freely move, so this electricity can pass through them easily. So example of electrolytes other than ionic these electrolytes are ionic solids is sodium chloride and potassium chloride. When these are in molten state or when these are in aqueous form, they can conduct electricity. So next type on the basis of conductivity that we explained previously is about insulators. So materials that do not allow the electricity to pass through them that are called insulators. So insulators have very low conductivities that are in the range of 10 raised to power minus 20 to 10 raised to power minus 10 per ohm per meter. So if we take examples of insulators from our daily life, then we can see glass, wood, plastic, ceramic, rubber, fabric, wool, or cork are example of insulators. Electricity cannot pass through them, so they are examples of insulators. And from other materials, we can say that sulfur, phosphorus, or vanadium pentoxide are examples of insulators. So next type is semiconductors. So materials whose conductivity lies between metallic conductors and insulators that are called semiconductors. So we can say that semiconductors have conductivity between insulators and conductors. So their conductivities are in the range of 10 raised to power minus 6 to 10 raised to power 4 per ohm per meter. So examples of semiconductors are germanium, silicone. In this figure you can see that here are silicon chips, that is example of semiconductors. So electrical conduction, we can say that for electrical conduction the main source is source are electrons. So we can say that electrons are a major charge carriers which can conduct electricity. So in case of metals, we can divide into energy bands into three types. One is a core band, valence band, and conduction band. Here we will discuss these bands in detail. So a core band is that band in which electrons are not involved in bonding. So in our topic, we are considering electrical properties in which we consider conductors or conduction. So in case of conduction or conductors, semiconductors, these two bands are involved. That one is a valence band and another is conduction band. So a valence band involves, it is outermost shell that comprises of valence electrons, and it has a lower energy than that of conduction band. And conduction band consists of free electrons that are responsible for conduction, and in metals and alloys mostly these free electrons are able to conduct electricity. So a valence and conduction band are two different energy levels that are separated by a certain amount of energy. There is an energy gap between valence band and conduction band, and that band is known as energy band gap. Next, I will show you these valence band and conduction band and mechanism of electrical conduction, and we will discuss energy band diagram, that how they lie, conduction band and valence band, how they are arranged, and what is in different conductors, semiconductors and insulator, what is the difference of this energy band gap between them, and how electrons can move from valence band to conduction band. So what is mechanism of electrical conduction? So there is a band model, as we explained that in electrical conduction we take two bands into consideration. One is conduction band and other is valence band. So in conduction band, and this is known as band model. So valence band is actually outermost filled energy band, and conduction band is empty energy band, or it can be partially filled band. So if there is an electron, when electron move from valence band to conduction band, then it needs some energy. So the distance between valence band and conduction band is known as energy gap. So when electron moves from valence band to conduction band, they have to overcome this energy gap. The distance between valence band and conduction band is known as energy gap. Here, conduction band may be fulfilled, or it may be empty, or it may be partially filled, and valence band is the outermost filled energy band. And so for metal conductors, semiconductors, and insulators, energy band could be like this. This is increasing order of energy. In case of metal conductors, you can see here, this is valence band and this is conduction band, and there is a no energy gap between valence band and conduction band. So for electrons, it is easy to move from valence band to conduction band. In case of metal conductors, valence band may be energy gap between valence band and conduction band may be zero, or it may be very less. So energy gap here is 0 electron volt. Here no energy is required to jump electron from valence band to conduction band. In case of semiconductors, these semiconductors lies between metal conductors and insulators. Conductors are those materials which can pass electricity, and insulators are those materials from which electricity cannot pass. And semiconductors have characteristics between metal conductors and insulators. So in case of semiconductors, valence band and conduction band has energy gap. So as compared to metal conductors, their energy gap is bigger. So in case of semiconductors, in this case we can say that energy gap is 1 electron volt. So electron have to jump after getting energy of 1 electron volt, it can move to conduction band. So in case of insulators, here is a valence band, this is conduction band, and you can see that the difference between two bands is very large. Energy gap is very large, so in insulator it is impossible for electrons to jump from valence band to conduction band. So in this case, much higher energy is required to jump from valence band to conduction band. So in this case, we can say that energy gap is about equal to 5 electron volt. So in case of metal conductors, this energy gap is 0, or it may be very less. In case of semiconductors, energy gap is smaller, but smaller than insulators, but larger than metal conductors. In case of insulator, this energy gap is very large, so it is difficult for electrons to move from valence band to conduction band. So in today's lectures, we discussed about valence band and conduction band in detail. So there is assignment for you that you have to uh, complete. You have to differentiate between valence band and conduction band, and what are their you can compare them. What is valence band and conduction band? What are their similarities and what are their differences?